We're on lesson 5 of chapter 6, which is solving special types of linear systems. First, we're going to do linear systems with no solution. Then we're going to do linear systems with infinite solutions. Then we'll solve a real-world problem. So far, we've been learning how to solve linear systems with substitution, multiplying, adding, and subtracting. And they've all been working out for us. But sometimes these special types of linear systems throw everything off. For example, we have 5x minus 2y equals 16. Then we also have 10x minus 4y equals 20. Well, if we follow our multiplication rules and multiply this top line times 2, we would end up with 10x minus 4y equals 16. Then we would have 10x minus 4y equals 20. How can 10x minus 4y equal the same thing? And you're okay if this confuses you. This means that there are no solutions. So that's because if we subtract here 10 minus 10 and then negative 4 minus negative 4, this would be 0 equals negative 4. And then this is an impossible answer, so there are no solutions to this system. And that happens once in a while. Sometimes there are an infinite amount of solutions as well, so let's take a look. This one says, show that the linear system has no solution. And this is what we meant before. We're going to show this in two different ways. We're going to show it by graphing, but also by our algebraic method. If we're going to put this in a slope-intercept, this would turn into 2y equals negative 3x plus 10. 2y equals negative 3x plus 10. Divide both sides by 2. So then we're left with y equals negative 3 over 2x plus 5. So if we plot this one out, we go to the y-intercept of 5. Then we fall 3 and run 2. So run 2, down 3, run 2, down 3. And then using those points, we could plot out a line and move it back. So there we are. Now the second one, we have 3x plus 2y equals 2. So if we made that into slope-intercept form, we would have 2y equals negative 3x plus 2. Divide everything by 2. That would give us y equals negative 3 over 2x plus 1. So we'd plot our y-intercept at 1, using red this time, and then fall of 3 over 2. Let's go backwards to give us one more point. So over 2, rise 3. Then we can plot out our points. And I didn't plot this out perfectly, but you can get the idea of what's happening. The slope, as we see, negative 3 over 2x, is exactly the same, which means that they're going to be parallel. And we know that parallel lines never touch. And when we graphed solutions, we looked for that intersection. Well, if there's no intersection, then there is no solution. So that's one way to show that there's no solution, showing those parallel lines. The other way is to eliminate here. If we subtract both sides, that would give us 3x minus 3x is 0. 2y minus 2y is 0. 10 minus 2 is 8. 0 does not equal 8, meaning that this is not a solution. So this is one way to show that. This is the other. Now we need to show that this linear system has infinitely many solutions. So let's do the graphing method, then we'll do the algebraic method, and we'll show that in two different ways. If we do the graphing method, we make this slope-intercept form. We have x minus 2y equals negative 4. We can subtract x from both sides. If I'm going to rewrite this, I'm going to call it negative 2y equals negative x minus 4. Then we can divide by negative 2 on both sides. And that would give me a positive y equals, that'd be 1/2 x positive, and then minus negative 2 or plus 2. So here's my slope-intercept form equation. Compare that to the other one, and you'll notice this looks exactly the same. Y equals 1/2 x plus 2. That's because these two equations are the same. So now let's plot them. Y equals 1/2 x plus 2, slope-intercept at 2. Rise of run is 1 over 2, so run of 2, rise of 1, 2, 1, going backwards now. Then we could plot our line. So I only need to plot this once because the lines are exactly the same. They're right on top of each other. And if you remember when we graphed these linear systems before, it was where it crossed that counts. If you notice, if they cross everywhere, that means every single thing on the line would be a solution. And that would make sense, because if it's true in this statement, it's going to be true in the exact same copy as well. To show this is the case algebraically, we can do the substitution method. See, we have y equals 1 half x plus 2. 1 half x plus 2 is the same thing as y here, so let's plug that in. X minus 2 times 1 half x plus 2 equals negative 4. So we have x and then minus. Remember, we have a negative 2 times 1 half x, so we treat that as a minus here. So 2 times 1 half would just be 1x, so minus x. And then minus again because we're multiplying the negative, and minus 4 equals negative 4. Well, we see x minus x would be 0. So 0 minus 4 equals negative 4. Add 4 to both sides. And what do we get? We get 0 equals negative 4 plus 4 is 0, meaning that this is a true statement, meaning that all of our equations are going to be true. So that's the algebraic way. This is the graphing way. Both are great methods to show this. Let's do a real-world problem. An artist wants to sell prints of her paintings. She orders a set of prints for each of her 2 paintings. Each set contains regular prints and glossy prints as shown in the table. Find the cost of one glossy print. So we've done things like this before. So we see that 45 regular plus 30 glossy equals 465. So if we did 45x plus 30y equaling 465, and then 15 and 10 equaling 155, so 15x plus 10y equaling 155, we could find out the amount of price. We could do the multiplication method to solve these ones then, multiplying these times 3. So on top we would still have 45x plus 30y equals 465. On the bottom we would have 15 times 3, which is 45x, plus 30y equaling 155 times 3. 155 times 3 is 465. If I subtract all these, this would be 0 plus 0 equals 0. And this shows to be an equation with an infinite amount of solutions, meaning that we can't solve this right now. I can't solve for x because x gets eliminated. I can't solve for y because y gets eliminated. So therefore, I'm out of luck. I can't tell her how much a regular print is or how much a glossy print is. If you'll notice here, the proportions are all the same. 15 and 45, 10 and 30, 465 and 155. If this was 31 or 44 or 16 or 11, then I could have, because the proportions would have been off and I would have been able to solve the difference. But since they're proportional, that makes it too difficult.